Welcome back. This is our final video in the guided tour of the Boilermaker code scaffold. It's been a long road, but now we're going to talk just a little bit about deployment and continuous integration. The reason is because we have two different ways to deploy in Boilermaker. Both have strengths and weaknesses, as is always the case in code. There's trade-offs. One is a manual script that's an npm run deploy, and that runs a script file, which we'll show you in a short bit. The other is a configuration file for a third-party service called Travis. And Travis handles both automated testing and automated deployment. We're not going to show you deployment today. We're not going to go into detail because usually the instructors will actually give a lecture on that during senior phase. But we will talk in a high level, just conceptually what's going on and what you would have to know going into that sort of lecture. So I think let's start with the manual deploy script because that is actually part of the code base. Now, while he's pulling up deploy here, this is a shell script. So we've got that shebang at the top, that hash bang. And this is a way for whenever a shell script is run, the script can tell the environment what executable actually is able to run this.
Right, and the npm script actually is just script/deploy. Now, this can sometimes be a problem permissions-wise. Let me just briefly go into that.
Yeah, so take a look at the specific, like is it executable, etc.
Right. Okay. So I usually do HAL capital F just because it's easier to remember.
Yeah.
But really, the one that you need to see this information is L. Okay. And this gives me a lot of stuff. I'm gonna just make this a little wider for now, so you can see the whole thing all in one spot. And here is the spec for the permissions. This first hyphen tells you whether it's a directory or not, and these other ones tell you whether you can read, write, and execute in certain contexts. Now, this is actually a binary number, encoded in perhaps the worst way imaginable, because each of the letters merely represent a 1 or a 0, and the hyphens are zeros, and the letters are ones. And so these letters come in bit triples, which are called octets, because 3 bits you can represent 0 through 7, which is 8 numbers. And further, the UNIX tools that you use to actually change this they work in octal for some reason. I don't know. But the way you...
A running theme with like POSIX is that it's just a mess of old, crufty, random decisions people made that all built on each other and we can never get rid of because backwards compatibility is important. So it's a lot of arbitrary decisions, which maybe had good reasons at the time, but they're really inconsistent. And you get this pile of stuff like this.
Right, and so RWX stands for read, write, execute, as I said. And so I'm going to turn off the execute bit in all 3 octets. Now, the first octet is owner. The second one is group, and the third one is everyone. And so you can see on this file, here is my owner and group information. I am the owner, and staff is the group. And anyone else who's if they're not in the staff group would have these permissions, read and execute. So I'm going to turn off the execute bit in every octet. So I need 110, 100, 100, and 110 in binary is 6. 100 is 4. So I'm going to use the arcane invocation chmod script, and I have to put the octets first, 644 script deploy here. And whenever I look at it again, I can see those X's are gone. Now, I did this so that I can show you, if you're trying to make your own script, this is what you will get if there's a permissions error. So I'm going to do /script deploy. Now, I, strictly speaking, didn't need the /, but but anyway, so permission denied, and this is merely Unix permissions. It's not that I'm doing something bad, right? I didn't try to, circumvent some sort of, lockdown. It's just that Unix permissions, you have to have the execute bit set if you want to execute it.
Yep. So it's almost like an indirect / misleading error message, because it's not that you are the wrong person. It's that it looks and says, is this person allowed to execute? No. So the real error is we forgot to make this script executable.
Right. So let me show you how to do that again. Okay, so we started off, we were 644 at this point, and we want to go back to whatever this was. And this is 111, 101, 101. And 111, that's 7. And 101, that's 5. So I want to chmod 755 script deploy. You're right. I should have been quizzing you on it. That's and then I can run it. It should break. Yeah, but it's doing something. But it doesn't matter. I don't want it to continue. Let's see if I can clear this. I get a branch. Yeah, okay. I think there's nothing in here that matters.
Yeah, I think it's fine. We don't need to worry about it.
Yeah.
So if you could turn it off for a second, go back to without the executable flag. I'll show them a small shortcut. I think it's important that they understand that they can set all of the settings with these numbers.
Oh, right, yeah.
But there is a shortcut. If you just want to make it executable, you've made a file, you can, and you don't want to like worry that you're going to do the wrong base conversion, you can do chmod plus X, which means add the executable number to all of this stuff. And now when we take a look at it, all three of those groups, the user group and what was the third one? It's
everyone.
Everyone, yeah. Have that X flag on it so they can all execute this script.
Yeah, that's an unusual invocation as well with the plus.
Yeah.
There are a few commands that are like that. Chmod is one. Set is another one. It's not typical to run across a flag that you precede with plus.
There's another thing I'd like them to see about this. If you could look at the GitHub page for it.
Okay. Yes.
If you check out, not literally check out, but if you click, go into script, and then click on seed. You look at the top. 59 lines, 1.8 kilobits. Maybe at the bottom? I know it says it somewhere. Go back up to the top. It's funny because I know for a fact that one of the things that is actually stored in Git about files is whether or not they are executable. Mm-hmm. In fact, they don't store other permissions, which is interesting to me. But they do store that executable flag, that like whether it is or isn't. Normally, there's somewhere tricky, like in a corner or something in GitHub, where you can see an indication of that, and you get, oh, right there, executable file. I hit seed, which isn't executable.
Right.
But this one says it is an executable file.
And you can tell that a file wants to be executable or not based on the shebang line. If it has a shebang line, then it is intended to be an executable file. And
although it might not be if it doesn't have the right permissions.
Right.
Yeah. Okay, so we've seen that this is a bash script. It has the shebang. It is executable. So what happens when we execute it? Well, very high level, the idea of this deploy script is that it is going to switch to a new branch called deploy. It's going to run Webpack in production mode to build a minified compacted bundle.js. It is going to make a commit that puts everything together. And normally bundle is ignored in git ignore. But we actually want the bundle to be included in the deploy. So we add the bundle using the -f for force flag. Be careful with that -f. It is a dangerous thing to know about. So we force add the bundle to our git commit. Now we've created a branch deploy that is your project plus one commit, including the bundle in it. We add a commit. We have a special edge case where sometimes like you might want to deploy again, even though you haven't actually changed anything. So we do this allow empty. It's like, just force it to be a new commit. And then we put it up to this Heroku deploy master remote. This we didn't show you, but at some point, if you wanted to be able to deploy, you would set up an account with Heroku, you would initialize a new app with Heroku, you would download the Heroku command line tools, and you would initialize this repo as corresponding to a particular Heroku app. And that would create a Git remote called Heroku that it can go look at and push stuff up to. And that's really it. Like all we're really doing is pushing a Git commit that includes the bundle up to Heroku.
Mm-hmm. Yeah, and this allow empty, just going back to that, almost always you don't need to do a redeploy. Most of the time you can just do a restart with the Heroku command line. But there are, I can conceive of situations where you would need to redeploy, so I'm not going to say never, but...
Yeah, I think we also did it just to kind of like have the expectation that if I run the deploy script, it will deploy.
Yeah.
And we didn't want to confuse students in the case where like, it's saying I can't deploy. It's like, well, you already deployed.
Right.
Another thing that's tricky about this bash script, which I like, is another example of something we talked about in earlier videos, which is resource cleanup. So here we automatically create this trap. saying if the exit trap is invoked, call this function cleanup at exit. Cleanup at exit goes back to the master branch and deletes this temporary deploy branch. That's all it does.
That's good.
Yep. And I like that it gives you an example of sort of like hooks in Bash. Okay, that's pretty much it for manual deployment. The instructions for this, by the way, are totally in the README. If we go look at the README, it gives us very detailed instructions about how to get the Heroku command line tools, create a Heroku remote, call the deployment script, etc. And we got to do that no matter which version of deployment we use. If we go down to option B, which is the manual deployment, we could see that this is like npm run deploy, it does the script, and it describes exactly what we just described in video format.
Right, and as we were talking about earlier with integration tests, again, just having it available and having it deployed is very important. And the reason it's really important to have it deployed is if someone else wants to look at it, they shouldn't have to clone npm install, npm run start dev. They should just be able to type in a URL.
Yeah.
And deploying really makes you do that.
Yeah, forcing people to know what your project looks like by building your project is kind of a slog. It happens a lot, but it's, especially when you've got like make files or things that like C++ needs to compile for a good 10 minutes just to use the thing. It's like, I wish that you had a distro somewhere.
But we're operating on the web, and we can suspend all those rules because the browser is our playground.
Yes.
And as long as we deploy it, anyone else can view it.
Yes, which is great. So the other version of deployment that is a little bit more sophisticated, has a slightly higher setup cost, but over time is much more useful, is automatic deployment via continuous integration. The idea of continuous integration is that instead of having occasional big releases with a whole bunch of new features, your developers are constantly pushing new features directly into the deployed app. The way we enable that is we have Travis, a third-party service, monitor our GitHub. Every time new code goes into GitHub, it will automatically test it. If the tests pass and the new code gets fused into the master branch, not only will it automatically test it, it will then take that updated master branch and put it into Heroku for us. So our master branch on GitHub is both protected by tests and it is synonymous with the live deployed app. It is the same thing.
And this continuous integration, I think, goes back to what we were saying earlier about committing frequently. Committing frequently is important, and if you're committing to master, now every time you commit to master, you're going to be deploying. And deploying frequently is also important because let's say you deploy something and you're not happy with it. You want to revert. It's much easier to revert to a previous deployment whenever that previous deployment isn't that much different than what you have currently deployed.
For sure. So the way we would do this is not only would we get the Heroku command line tools and set up our Heroku deployment to start, we would also follow these instructions to get the Travis command line tools and install them locally. There is a configuration file built into Boilermaker that sets the options for Travis. Now, when I first started looking into continuous integration, we were talking about this before the break. Thing that I struggled with was I didn't like the idea of putting a settings file for a third-party service in my code base. That felt like backwards to me because the code should be for the project and other services should be their own thing and they should have their own settings and they're in like a web GUI or something. What I gradually came to understand or feel over time is while there's an element of truth to that, it is so convenient to having your settings file be directly linked with the current state of your project, to actually live inside a Git commit, so that if I go to different branches or I revert to different commits, the settings are associated with that particular way the project looks at that time. And it knows about the scripts that are in that package.json, and it knows about the files that are in that file tree. And that is very powerful. As opposed to with something like CodeShip, the settings do live in CodeShip, which is another service like Travis, but there's no way of saying use this settings for this commit and this other settings for this other commit. And that turns into a big chore, keeping that up to date.
Right. So, and as a consequence of what you just said, Travis YAML is not referred to in package.json because it's not part of our node package. It's separate. It's for deployment only. And we can still look at it though. It's still here. It's but it is hidden. So it's a .travis YAML.
Yep, private file. And it's got two big sections. The first section is uncommented, and the second section is commented out currently. The first section is all about continuous testing. This is not deployment per se. This is just having Travis as a form of a watchdog, so you can have Git branches like master protected. Travis will check any pull request anybody makes and automatically run this configuration to test the code. If the tests pass, you get a lovely little green check mark in GitHub, and you can merge the code in. If the tests fail, you can set it up so GitHub prevents you from accidentally merging that code into your master. Mm-hmm. Let's take a look what's in here. It's pretty much all setting stuff. It's really like look at the docs kind of config stuff. It says we're a node project, which means use package.json and npm and install and run. We do have Postgres as part of this project, so we need to start up Postgres on Travis. I've put in a version number, so we're using a very recent version of Postgres, at least as of this video. The next two things are special Linux kind of config stuff. There's this trusty thing, which sounds like, oh, am I saying to trust the code or not? And it took me a really long time, an embarrassingly long time, to find out trusty is the name of just a version of Linux. Mm-hmm. So it's saying use a very up-to-date version of Ubuntu. And sudo is saying, okay, we're not going to like have total access, which means you don't have to start up a whole new Linux box from scratch. We can actually, since we're not going to use sudo, it can feel comfortable running our code inside of a Docker container. Mm-hmm. We don't have to set this up. Travis does this. But the advantage is this will be a lot faster. Travis can like launch this Docker container very quickly, as opposed to starting up a whole new machine from scratch.
And also, if you're in the queue, if you're in the queue for a whole new machine, as you said, that's going to take longer than if you're in a queue for merely a Docker container.
Yeah. So the combination of that trusty, which has Docker support, and sudo false, which enables Docker support, gives us the fastest version of starting up a node project on Travis that I could come up with. These email notifications are self-explanatory. It's like, do you want to get emails about it? And the install command is, instead of saying npm install, which checks package.json against package lock and then does some other stuff, it just goes reads package lock and just dumps all those into your node modules. Mm-hmm. So in theory, that's the fastest possible way to npm install. And in fact, this command was literally made for continuous integration services like Travis for this purpose.
Right, and this is also why you actually do want to commit this generated file into your repo, because usually you don't take generated files and put them in your version control, but because the node environment uses this package lock and uses it for these sorts of deployment situations, this is where you want to use it. And it's also used in Heroku. This is how Heroku will install your node package. And that's another reason it needs to be in the repo, because when you deploy it, it needs to be on Heroku. And so there you go.
Yep. Finally, we have a hook here. We're saying before you run the npm install, make sure to create a testing database so that it can actually run the tests. And that's just a psql command. A command line psql command. Specifically, it's saying psql run this command create database as the user Postgres, because it doesn't know which user to use otherwise. And by default on Travis, the Postgres application has a Postgres user with no permissions that are set on it. So we can just be that user. The second part of this Travis YAML file is all about deployment. But before I even talk about that, I should mention, like we've said, like Travis YAML multiple times. I don't think we've ever told them what YAML is.
No, that's true. Yeah, it hasn't come up yet.
Yeah. So YAML, I can't remember, it's like yet another markup language or something like that, is a superset of JSON. It's a way of writing configuration files, static files, trees of data that is much more human-friendly than JSON, but it's also a lot more complicated because it's got so many options. So it's harder to like parse YAML files and deal with them from a spec or an implementer perspective, but it's much more free-form and a lot more terse than JSON. You don't have to use double quotes. You don't have to use curly braces. You use like significant indentation, sort of Pythonic or Haskell style. So it's a really lightweight, visually speaking, configuration format that's annoying from a programmatic perspective.
Yeah, and I want to just call attention to the three different kinds of configuration we have here. Okay, so we have this YAML file, which it's pretty, YAML, unfortunately, is too flexible to always look the same. So you may run into a YAML file and it looks like this. This is a very common way of making your YAML files. But you may run into something that looks even more like a JSON file. And in fact, JSON is valid YAML.
Yeah.
And a lot of times what I've seen YAML used for is JSON with comments.
Sure.
So the idea is JSON itself does not support comments. But if you have a very long JSON object and you want to start commenting in it, you can convert it to YAML and it doesn't have to change that much. But then we also have this actual JavaScript configuration file. And so this is actual dynamic JavaScript that can do things like these sorts of expressions. And deciding how your configuration lives, it's an important thing if you're making a new service. So like if you're deciding, oh, I'm going to make a Travis YAML, or I'm going to make something like Puppet, which is yet a different dependency management tool. And how you decide what the configuration looks like really determines the future of that. So
it's one of those decisions with outsized consequences.
Exactly, yeah. So, but YAML is a very common choice. Travis uses it here. Another place that you might see it along these lines is Docker Compose uses YAML. But it's funny because Docker uses Docker files, which is their own syntax, and Docker Compose uses YAML. So.
Sure. Yep. It's a mess. Coding is a mess if you haven't figured that out yet.
That's why we need stuff like Boilermaker to help us guide through it and let us ignore some of the more technical details.
Yeah, skip over some of the messy, just getting it set up and go straight into let's make cool new features.
Exactly.
Okay, so that whole first part was about continuous testing. We set up our environment. We start Postgres, we create a testing database, we npm install in the fast way, and then it's going to automatically run npm test for us. We didn't have to put that in there because when we tell Travis that this is a node project, it knows by default what I should run is npm test, and it will do that. The next step here, it's currently commented out, and that's because if I don't have this commented out, it actually won't run until you properly configure it. There are two things you actually need to put into this YAML file. The name of your Heroku app, which you find out after you make a Heroku app. Heroku gives you the name or you customize it. And a encrypted, I'm going to emphasize that, encrypted version of your Heroku API key. Do not copy paste your Heroku API key into this file, because this file does go into GitHub. It's supposed to go into GitHub, and it is totally public, and that's fine. Therefore, you should not be putting your private Heroku API key in here. So how do we do the encryption? There are instructions in the README. Basically, what we do is we run this command travis encrypt heroku auth token --org. Literally that command. You don't have to modify or edit the command in any way. --org is not code for insert your org name here. For some reason, I see students do that all the time. I don't know why. But literally just copy paste that command and run it locally if you've installed the Travis tools, and it will give you back gibberish. You copy paste that gibberish, put it into Travis YAML, save it, push it up as a branch, make a pull request, fuse it into your project. If Travis is already enabled because it's running your tests and stuff, from now on, your master branch will automatically get pushed up to Heroku.
Mm-hmm. And I know that storing your unencrypted API key in your Git repository and then pushing that and making it public, that's actually on the OWASP top 10 security vulnerabilities. I don't remember which one it is. But it's very easy to find these keys out there. If you do that, you can always invalidate your API keys. And so the idea is that you create a new API key, and then that will invalidate the old one, and then you can do the correct thing with the new one. But you want to avoid leaking any sort of secrets, but if you do, there are ways to fix it.
Yeah, you want to do it fast because the bots are crawling through GitHub constantly, just accumulating these things, and the black hats are at some point going to use them to do stuff. We've gotten students who got emails from Amazon saying, you owe us $100,000. And then they're like, oops, just kidding, that wasn't us. And Amazon's like, we're going to give you a one-time free pass on this $100,000 bill. But you don't want to abuse that. $100,000 is probably off by an order of magnitude. I think it was about $15,000, but it was legit, a lot of money.
It'd be a lot.
So something Dakota mentioned a second ago, I really want to emphasize that it is a two-step procedure to fix this problem. The two steps are you edit your code to take out the key and replace it, and put it properly into gitignore or whatever you do, or encrypt it or something. But you still need to invalidate the old key, and that does not happen in your code. If you have a service like GitHub or Facebook or Google that you got this key from, or Heroku or Travis or something, you have to go to that service and make sure the old key is defunct. You have to disable it, you have to make a new one which deletes the old one or something. But it's not just a code change, it's also an option you have to go back to the provider and do with them specifically.
Exactly, yeah. And it's very important, but any reasonable provider of such services, this is big, it's like make a new key or something like
delete this.
Yeah, it's a common enough thing.
Giant trash can icon.
Yeah, and a lot of people, sometimes they say, well, we should just update our keys regularly anyway. Yeah. And so that's another reason that this sort of thing is. Because even though this Travis encryption is using a state-of-the-art, well-attacked encryption scheme, that doesn't mean that it will never be broken. And so the shorter, more ephemeral the secrets that you have are, the better. And that's why HTTPS actually uses a different encryption every single time you have a session. And if you have one key for a long time, that just allows a potential attacker to spend all of that time trying to break it.
For sure. I find security interesting because it's a mix of very cut and dried binary choices, like this is secure and this isn't secure, but it's also a bunch of measures that are like, well, this is more secure. It makes things harder, or it makes it more obscure, or it reduces the chance that something will go wrong. And sometimes people look at those kinds of measures and they're like, well, it's not really secure because it might take 5 days instead of 2 days. And it's like, well, that's still better. So yeah, you're right. It's not actually, in the binary sense, this is secure and this isn't secure. But the more of those measures and features we compile on top of the easy, divided wins and loses, the more likely it is that we're just stacking the odds in our favor.
Exactly. And a lot of people get down on something called security by obscurity, where you have a secret and you hide it in a way, like you put it in a GIF or something along those lines, like in the comment of the GIF, and it's like, well, it's not really encrypted, but who even knows that GIFs have comments? Like, not that many people.
Sure.
So yeah. It can fool some people. Like even Da Vinci, he didn't have any good encryption tools, but what he did for his notes, or at least this is apocryphal, this might not be actually true, but he would write them upside down and backwards so that people couldn't read them.
Yeah, well, it is absolutely true that he did write some of his notes backwards. Mm-hmm. That's just a fact.
Mm-hmm.
The reason he would do it, people debate the exact historical reason. Right, yeah. But I love that you brought that up as an example.
Yep.
And it's really amazing because it's like, he wrote backwards fluently. Like, it is, the handwriting is perfect. And it's just one more thing that's like, wow, like that guy had a very unique brain.
Yeah.
Okay, that's pretty much every single file in Boilermaker. I don't think that we skipped a single file. We maybe did, but if we did, it probably was nothing, really worth spending tons of time on. I hope that you like these videos, that you got something out of it. And of course, if you've got any other questions, please Slack your fellows, Slack your instructor, meet up with them, ask them more questions, play around with this stuff. It's all there for you to hack and experiment with. That's the reason we made this stuff. So thanks a lot, and look forward to seeing what you all built with it.
Yeah.
Bye.